Hello everyone. Today I am going to discuss about the AC bridge in electronics and measurement system, which is one of the most important part in electronics measurement. Initially, we need to know what is AC bridge. AC bridge methods are outstanding important for measurement of electrical quantities, measurement of inductance, capacitance, storage cell, loss factor may be made by conventionally and accurately by employing AC bridge network. AC bridge are the circuits that are used to measure of electrical quantities such as inductance, capacitance, resistance. Along with this, an AC bridge allows us to measure storage factor, loss factor, dissipation factor. AC bridge operates with only AC signal. Here we can see the AC bridge network. An AC bridge consists 4 nodes with 4 arms. Source and detector in an AC bridge network are connected in opposite nodes. This is so because if source and detector are connected to the same node, all the voltage or current of the source will be displayed at the detector. So, in this condition, the bridge will never come into the balance condition. Basically, there are two conditions in order to balance the bridge. The detector current should be 0. The potential difference between the detector and node should be 0. Before knowing details about the AC bridge, we need to know the Wheatstone bridge. This is the circuit diagram of Wheatstone bridge. It is an AC bridge in a derivative of Wheatstone bridge. This is so because if battery and the galvanometer of a Wheatstone bridge are replaced by the AC source and detector respectively, it will behave like AC bridge. In case of low frequency measurement in an AC bridge, the power line may act as a supply source. In case of high frequency measurement, electronics oscillator are used as the supply source. Headphone, vibration galvanometer and tunable amplifier are commonly used as detector in AC bridge. And this is the balance equation of Wheatstone bridge, and you can see in this Wheatstone bridge we have to calculate the impedance value of each arm, and you can see the equation from the circuit of Wheatstone bridge. Now we are going to discuss about the Maxwell inductance bridge. The bridge circuit is used for medium inductance and can be arranged to yield the result of considerable precision. In the figure we can see in the two arms there are two pure resistance, so that for balance relation the phase balance depends on the remaining two arms. In Maxwell bridge we need to calculate the inductance. The inductance is L1. Here the different value, you can see the different value, such that L1 is the unknown inductance, L4 is the variable inductance, R4 is the variable resistance, R2 and R3 are the fixed resistance, and from there you can calculate the balance equation, and from there we can calculate the unknown resistance and unknown inductance, and from the unknown resistance and unknown inductance we can also calculate the quality factor of this bridge. Here you can see the Maxwell inductance bridge diagram as well as the phasor diagram of this bridge. This phasor diagram, you have to know the details about the phasor diagram, so you can make this from the circuit diagram. In this circuit there are two current, the I1 current and I2 current, and I put the I1 current in the x axis and I2 current in the y axis. From there we can draw the phasor diagram of Maxwell inductance bridge and other bridges also. Now we need to know the Maxwell inductance capacitance bridge. This is the Maxwell inductance capacitance bridge, where you can calculate from the name. You also understand from this bridge we can calculate the unknown inductance and capacitance value, and the procedure same as the Maxwell inductance bridge. And this is the bridge, and In this bridge, the inductance is measured by the comparison with the standard variable capacitance. One of the ratio arm has to resistance and the capacitance in parallel. And here you can see the mathematical expression of Maxwell inductance capacitance bridge, where L3 is the unknown inductance, C is the variable standard capacitor, R1, R2 and R4 are the known pure resistance, and R3 is the effective resistance of L3. And you need to balance the bridge with the help of the impedance value of each arm, and from there we can calculate the unknown inductance with respect to variable standard capacitor, and from there we can calculate also the quality factor of Maxwell inductance capacitance bridge. And from Maxwell inductance bridge we knew that the phasor diagram from the circuit diagram, and here the Maxwell inductance capacitance bridge, here we can see the Maxwell inductance capacitance bridge. From the bridge we can draw the phasor diagram, and you can see the phasor diagram here. Now we need to know the Maxwell inductance capacitance bridge advantage or disadvantage. The main advantage of Maxwell inductance capacitance bridge is the balance equation is independent of frequency, and it is useful for measurement of wide range of inductance at power and audio frequency. These are the advantages of Maxwell inductance capacitance bridge. Among them, there are some disadvantages in Maxwell inductance capacitance bridge. The disadvantages are it cannot be used for measure the high quality factors. It cannot be used for measure of very low quality factor because of balance problem. This is a de-Sautis bridge. This bridge is simplest method of comparing two capacitance, and from there we can calculate the value of the capacitance. And here you can see the different equation. From the equation we can calculate the unknown capacitance C2, because C2 is the unknown capacitance, C3 is the standard capacitor, and R3 and R4 are the pure resistance. Same method. And from that method we have to calculate the impedance value of the each arm, and from there we can calculate, or you can get the value of the C2, which is the unknown capacitance. And this is the phasor diagram of de-Sautis bridge. You can see the de-Sautis bridge as well as the phasor diagram. Now the advantages of de-Sautis bridge are, this bridge is very simple and it is very cheap. But the main disadvantages are, if both of the capacitor are not free from the dielectric loss, then it is not possible to achieve bridge balance. This method is only suitable for the measurement of lossless capacitor. And this is the Anderson bridge. This bridge is the modification of Maxwell inductance capacitance bridge, and from this Anderson bridge we can calculate the standard value of the capacitor. And this is the mathematical calculation of Anderson bridge, same as the previous bridges, and here we can calculate the impedance value of the each arm, and from that impedance value at balance condition we can find out the value of the inductance, capacitance, and as well as the resistance. And this is the phasor diagram of Anderson bridge. In the left side the diagram of the Anderson bridge, on the right side you can see the phasor diagram of the Anderson bridge. The advantages of Anderson bridge are, the Anderson bridge balance is easily obtained for low quality coils or low quality factor. The bridge can be used for accurate determination of capacitor in terms of the inductance, but the main disadvantages are, it is very complex. The bridge balance equation are not simple, they are rather more complex. Now we are going to discuss the sharing bridge. It is the standard bridge from where we can measure the unknown capacitance value. It is used mainly to measure the capacitor. It is useful for measuring the insulating property, such as phase angle vary nearly 90 degree. One of the ratio are consist of a resistance in parallel with the capacitor, and the standard term consists only a capacitor. The standard capacitor is a highly quality mica capacitor or an air capacitor for the insulation measurement. Same method, here you can see the mathematical calculation of the sharing bridge, from where we can calculate the unknown, we can find out the value of the unknown capacitance with respect to the other component like resistance, capacitance and other capacitance. In each bridge you have to remember, we need to calculate the impedance value of the each arm. From that impedance value we have to calculate the final value of the capacitor and others variable. And this is the phasor diagram of the sharing bridge. You can see the left hand side the sharing bridge circuit, and the right hand side the phasor diagram of the sharing bridge. The main advantages of sharing bridge: the bridge is widely used for the testing small capacitor at low voltage with high precision. Since the capacitor is a variable decade capacitor box, its setting in microfarad directly gives the value of the dissipation factor. These are the advantages of sharing bridge. And the disadvantages: the calibration of capacitor is only for particular frequency, as angular frequency term present in the equation. Commercial sharing bridge measure the capacitor from 100 microfarad to 1 microfarad within plus minus 2% accuracy. And this is the Hay bridge. Hay bridge is the modified of Maxwell bridge. In this bridge, the electrical resistance is connected in series with the standard capacitor. And from the Hay bridge, we can calculate the value of the inductor. And here you can see the equation of the Hay bridge. Same method, you have to calculate the impedance value of the each arm. From there, you can calculate the impedance value and the resistance value. And this is the phasor diagram of a Hay bridge. The advantages of Hay bridge: the bridge gives very simple expression for the calculation of unknown inductor of high value. The main disadvantage of Hay bridge is it is not suitable for measurement of quality factor less than 10. Now the wind bridge. The wind bridge is only of many common bridges. Wind bridge is used for precision measurement of capacitance in terms of the resistance and frequency. It is also used to measure audio frequency. And this is the wind bridge calculation. Now we are going to discuss the advantages of wind bridge. By varying the two capacitor values simultaneously by mounting them on common shaft, different frequency ranges can be obtained. The perfect sine wave output is possible, and it is useful to measure the frequency range up to 20 Hz to 100 kHz. The main disadvantages of wind bridge are the frequency stability is very poor. If instead of op-amp transistor is used, amplifier is to be used, then more stages are required to obtain 0 degree phase shift between input and output. These are the main disadvantages of wind bridge. Now we are going to discuss about the Q meter. The Q meter is a piece of equipment used in testing of radio frequency circuit. It has been largely replaced in professional laboratories by other types of impedance measuring device, though it is still in its use among radio amateurs. Now we are going to discuss about the detail of Q meter operation. It consists of self-contained variable frequency oscillator. The oscillator delivers current to a low value shunt resistance. Through this resistance, a small value of voltage is injected into the resonant circuit. This voltage is measured by a thermocouple voltmeter. Since the value of the shunt resistance is very low, it introduces almost no resistance into the oscillatory circuit and therefore represent a voltage source of magnitude with a very small internal resistance. A calibrated standard variable capacitor is used for resonating the circuit. Electromagnetic voltmeter or electronic voltmeter is connected across the capacitor. The coil under test is connected to terminals of two temperature. Now RLC meter. RLC meter stands for resistance, inductance and capacitance. In the simple version of the instrument, the impedance was measured internally and converted for display to the corresponding capacitor or inductance value. More advanced design measure true inductance or capacitance as well as the equivalent series resistance of capacitor and Q factor of inductive components. Thank you everyone. If you have any question, please free to contact on the given contact number and the mail ID. Thank you.